Okay, good morning. Today's lecture is about nuclear chemistry, and in that nuclear chemistry, we are going to see today liquid drop model as well as the collective model. Now, first will be liquid drop model. Now, in this liquid drop model, what they have said, what I have written here, explanation of nuclear fission on the basis of liquid drop model, oblique Bohr-Wheeler theory of nuclear fission. Now, how the nucleus is being split into two nucleus. For that, they have given this theory. सो यहाँ पे तुम लोग देख सकते हो कि इनिशियली मेरे पास जो न्यूक्लियस है ये एक तरह से सर्कुलर फेज पूरी तरह से स्पेरिकल शेप में है एंड इट इज कॉल्ड एज द योर मेन न्यूक्लियस। यहाँ पे कैसा होता है कि ये अगर मेरे पास यूरेनियम 232 है और ये जो यूरेनियम 232 है इट इज इनिशियली हैविंग आई विल से इट इज अ नॉर्मल न्यूक्लियस, it is my main target nucleus, and when some projectile means lighter elements such as neutron या फिर यहाँ पे अल्फा पार्टिकल आएगा, बीटा पार्टिकल आएगा, जब इसके ऊपर हिट करेगा तो एट दैट टाइम व्हेन प्रोजेक्टाइल इज गोइंग टू हिट ऑन द टारगेट एट दैट टाइम इट विल फॉर्म अ स्पेरिकल कंपाउंड न्यूक्लियस। और वो जो न्यूक्लियस है वो मैंने यहाँ पे निकाला हुआ है नीचे, दिस इज द स्पेरिकल कंपाउंड न्यूक्लियस। अभी यहाँ पे ये स्पेरिकल शेप का क्यों है? बिकॉज ऑफ द सरफेस टेंशन। तुम लोगों को पता है सरफेस टेंशन की वजह से शेप जो होता है वो स्पेरिकल बन जाता है, ठीक है। फिर अगर इसके अंदर जो भी न्यूक्लियॉन्स है तो न्यूक्लियॉन्स क्या करेंगे एक दूसरे के साथ, बिकॉज ऑफ द काइनेटिक एनर्जी देयर विल बी सम सॉर्ट ऑफ ऑसिलेशंस। तो वो ऑसिलेशंस होने की वजह से इसका जो शेप है वो चेंज हो जाएगा एंड इट विल बिकम इलिप्सॉइडल। as you can see here the shape is being going shape is changing into ellipsoidal shape। फिर ये ellipsoidal shape change हो गया तो इसके बाद अगर वो जो काइनेटिक एनर्जी की वजह से जो ऑसिलेशन हो रहे हैं वहां पे इन दैट न्यूक्लियस, तो विद इन द न्यूक्लियॉन्स, तो वो अगर बहुत ज्यादा फास्ट है तो ये जो शेप है इलिप्सॉइडल इट विल चेंज इनटू डम्बेल शेप एंड देन डम्बेल शेप विल चेंज इनटू द क्रिटिकल शेप, क्रिटिकल स्टेट। और क्रिटिकल स्टेट यहाँ पे देख सकते हो, इसके बाद क्रिटिकल माना क्या, जिसके बाद अगर ऑसिलेशंस बहुत ज्यादा फास्ट है वहां पे तो तुम्हारा जो स्पेरिकल कंपाउंड न्यूक्लियस था वो दो न्यूक्लियाई में स्प्लिट हो रहा है। तो यही जो ये जो थियरी है ये अप्लाई होती है जब एटॉमिक बॉम्ब में स्प्लिटिंग बताते हैं। जैसे यूरेनियम जो होता है वहां पे टारगेट होता है और वहां पे न्यूट्रॉन जो होता है वो प्रोजेक्टाइल होता है। तो जब यहाँ पे बम्बार्डमेंट होती है तो एट दैट टाइम इनिशियली it forms the compound nucleus and it changes shape into this like this, and then it will form the two daughter nuclei with the emission of three neutrons and some energy। तो इस तरह से प्रोसेस होता है फॉर द न्यूक्लियर फिजन और ये अप्लाई होता है एटॉमिक बॉम्ब्स में वगैरह। तो यहाँ पे हम लोग पढ़ते हैं जो मैंने तुम्हें बताया हुआ है वही यहाँ पे लिखा हुआ है, तो इसको एक बार हमें पढ़ना है सिर्फ। अभी लिक्विड ड्रॉप मॉडल में कैसे बताया हुआ है ये मैंने न्यूक्लियस के लिए बोला है। तो इसी तरह से अगर कोई भी लिक्विड होगा तो लिक्विड का जो शेप होता है वो क्यों स्पेरिकल होता है? बिकॉज ऑफ द सरफेस टेंशन। उसके बाद उसके अंदर जो भी मॉलिक्यूल्स है तो वो जो रहता है उसकी वजह से क्या होता है वहां पे काइनेटिक एनर्जी की वजह से ऑसिलेशंस होंगे, ऑसिलेशंस होने की वजह से उसका शेप जो है वो चेंज हो जाएगा और एक जो तुम्हारा जो मॉलिक्यूल था लिक्विड ड्रॉप था इट विल स्प्लिट इनटू टू ड्रॉपलेट्स। तो ये तुम लोगों ने ऑलरेडी कोई पत्ते, जब हम सुबह में पत्ते देखते हैं अभी कौन से विंटर सीजन में, तो वहां पे हम लोग जैसे देखते हैं कि पहले जो कोई पत्ते पर एक ड्रॉप होता है वो अपने आप दो ड्रॉप में स्प्लिट हो जाता है। तुम अगर अच्छे से ऑब्जर्व करो तो एक बार देखना उसे, ठीक है। तो अभी इसका हम एक्सप्लेनेशन पढ़ते हैं। Bohr-Wheeler explains the phenomenon of nuclear fission on the basis of liquid drop model। तो साइंटिस्ट का नाम है बोर एंड व्हीलर। They explained this। नाउ जैसे कि वहां पे मैंने निकाला हुआ था कि पहले जो शेप था वो कैसा था, स्पेरिकल था, उसके बाद वो इलिप्सॉइडल हो गया, फिर वो कैसा बना, डम्बेल बना, क्रिटिकल स्टेट में गया, ये डम्बेल था, उसके बाद वहां पे एकदम क्रिटिकल स्टेट आ गई उसकी एंड देन इट्स स्प्लिटेड इनटू टू ड्रॉपलेट्स। सो फर्स्ट वो जो स्पेरिकल था उसके लिए ड्यू टू सरफेस टेंशन लिक्विड ड्रॉप हैज द स्पेरिकल शेप। सो रिमेंबर why it is having the spherical shape? Because of the surface tension. When an external force is applied, now when the external force will be applied on this drop, then and in that case the spherical shape liquid drop changes to ellipsoidal shape. तो इसका शेप जो है वो इस तरह से चेंज हो जाएगा अगर यहाँ पे हम लोग कुछ फोर्स अप्लाई करते हैं तो. Then if external applied force is large, the drop may acquire dumbbell shape as you can see there, and finally it will get splitted into droplets. Bohr and Wheeler, they applied the same analogy to nucleus, and according to that, when spherical shaped nucleus, which is the target which I have shown you as uranium-232, captures a lighter projectile, that is neutron, which is called the projectile, it forms the compound nucleus, which is spherical in shape, and the compound nucleus has extra energy due to absorbed projectile, which results in increase in kinetic energy of nucleons. तो यहाँ पे तुम्हें ध्यान क्या करना है, जब भी टारगेट के ऊपर प्रोजेक्टाइल का उसके क्या बोलते हैं हिट होता है, when the target hits the projectile, when the projectile hits the target, at that time it forms the compound nucleus, and in that case initially the compound nucleus will be having the spherical shape. Now the compound nucleus has the extra energy. अभी ये जो compound nucleus बन गया उसके पास extra energy आ गई कहाँ से, because of the absorbed projectile, and it will result in increase in the kinetic energy of the nucleons. तो उसकी वजह से जो उसकी kinetic energy थी वो थोड़ी बढ़ गई. So the extra energy set up a series of oscillations in spherical compound nucleus. अभी एक्स्ट्रा एनर्जी आने की वजह से वहां पे क्या हो जाएंगे, ऑसिलेशंस हो जाएंगे विद इन द कंपाउंड न्यूक्लियस, एंड ड्यू टू दिस द शेप ऑफ द न्यूक्लियस विल बिकम ellipsoidal. When the oscillations become violent, the nucleus acquires dumbbell shape, and finally it will be converted into critical state, producing two different nuclei. अगर वहां पे oscillations violent हो जाएंगे, then it will produce the two different nuclei. In the process, formation of two different nuclei from a single compound nucleus occurs, and hence it is the nuclear fission process. तो यहाँ पे एक न्यूक्लियस था तुम्हारे पास, उसकी वजह से दो न्यूक्लियर बन गए, so it is called as the nuclear fission process. Fission means breaking. Thus, the nuclear fission can be explained on the basis of the liquid drop model. So, what we have seen, just you will have to remember only this diagram, and you can write down all things on your own. Initially, you will be having your target nucleus, which is uranium-232, or it may be anyone, and then you will be having the projectile. When the projectile hits the target, at that time it forms the compound nucleus, which is spherical in shape, and because of the absorbed energy of the projectile, that spherical compound nucleus will change its shape into different shapes, and it will finally get splitted into the two daughter nuclei, and hence you can explain the nuclear fission on the basis of liquid drop model. So this is about the liquid drop model. Now, next theory is collective. Next model is collective model. So in this collective model, collective, as you can see, it means a collection of two models. Here, this model combined the Fermi gas model as well as the shell model and liquid drop model, and because of all the combination of all these models, it is called as the collective model. So in this model, first we will see the introduction. I will just show you what we are going to see here first. First we will see introduction, and after that introduction, this is the main statement for that collective model, and then there will be 3 points, main points. First, nuclear deformation due to nucleons outside the filled shells. Then second part will be collective rotation in even nuclei, and third part will be collective rotation in odd even nuclei. This will be third part, and lastly we will be going to see its merits, and this will be all. In exam they will just it may happen they will just ask you about the merits. These are the 3 merits, and these are asked for 3 marks for twice to thrice in Mumbai University examinations. So just इसका रट्टा मार के रख देना, समझ लो पहले एक बार अच्छे से और रट्टा मार के रख दो, ताकि 3 पॉइंट्स है तो एक भी भूलना नहीं चाहिए. 3 मार्क्स के लिए, 4 मार्क्स के लिए 3 पूछते हैं. So let's go into collective model. तो सबसे पहले कलेक्टिव मॉडल में क्या है? इट इज अ कलेक्शन ऑफ फर्मी गैस मॉडल, शेल मॉडल एज वेल एज द लिक्विड ड्रॉप मॉडल. नाउ आई एम जस्ट गोइंग टू रीड ऑल दिस. फर्स्ट, इंट्रोडक्शन. The Fermi gas model, nuclear shell model provide very important applications, but no single model can be considered as capable of explaining all the aspects of known behavior of nuclei, both in ground state and excited state. Means one of the model may explain the nucleus in ground state, and the next model will be explaining the nucleus in the excited state. So if we have to combine all these things, for that the shell model attributes many nuclear properties to the single nucleon lying outside the filled shells, and liquid drop model disregards the characteristics of individual nucleon. Firstly, they are showing what are the demerits of the earlier model. Fermi gas model, nuclear shell model, they combines. This model provides an important application, but no single model is considered as capable of explaining all aspects of known behavior of nuclei in both in ground state and excited state. So first demerit will be no single model is considered as capable of explaining all aspect of known behavior of nucleus both in ground state as well as in excited state. So this is first demerit. Then second, in the second case, the shell model attributes. Now there are उसको हम लोग क्या बोलते हैं कि देख पढ़ लेते हैं पहले, बाद में बताते हैं, वर्ड नहीं ध्यान में आ रहा क्या. द शेल मॉडल एट्रीब्यूट्स मेनी न्यूक्लियर प्रॉपर्टीज टू द सिंगल न्यूक्लियन. शेल मॉडल ने किस लिए बताया था? सिंगल न्यूक्लियन के लिए सब प्रॉपर्टीज बताई हुई है, न्यूक्लियर प्रॉपर्टीज लाइंग विच आर लाइंग आउटसाइड द फील्ड शेल्स. और जो लिक्विड ड्रॉप मॉडल है, इट इट डिसरिगार्ड्स द कैरेक्टरिस्टिक ऑफ इंडिविजुअल न्यूक्लियन. क्योंकि उसने जो हम लोगों ने जो देखा था लिक्विड ड्रॉप मॉडल ने, उसने क्या कंबाइन न्यूक्लियन जो होते हैं, जैसे एक स्पेरिकल शेप है, उसके अगर टारगेट, उसके ऊपर अगर टारगेट को हिट करता है या फिर तुम एक्सटर्नल प्रेशर अप्लाई करते हो, तो पूरे न्यूक्लियस के पूरे न्यूक्लियंस के अंदर ही वहां पे चेंजेस होते हैं, ऐसा लिक्विड ड्रॉप मॉडल में बताया हुआ है. लेकिन शेल मॉडल में हम लोगों ने देखा था कि कैसे वहां पे अगर तुम्हारे पास मैजिक नंबर ऑफ न्यूक्लियंस है तो तुम्हें स्टेबिलिटी मिलती है, अगर नहीं है तो स्टेबिलिटी इतनी नहीं होती है. तो हम लोगों ने ये शेल मॉडल में स्टडी किया था. तो शेल मॉडल गिव्स द न्यूक्लियर प्रॉपर्टीज फॉर सिंगल न्यूक्लियन, और लिक्विड ड्रॉप मॉडल disregards the characteristic of single nucleons or individual nucleons. तो ये second demerit था. Now this dualism, this is the word which I was not getting. So this kind of dualism has been overcome by incorporating the major features of the shell model and the liquid drop model into a single model, which is called as the collective model. And this model is developed by H. Bohr and B.R. Mortensen. So in order to overcome this dualism, the model is given by H. Bohr and B.R. Mortensen, and the model combines the liquid drop model as well as the shell model. Now this model treats the main statement for the collective model. You just have to must write down it in your exam if you are going to have theory exam. The main statement for this collective model is that the movement of the nucleus as a whole as the motion of unpaired nucleons. This model treats the movement of the nucleus. Why the nucleus is having movement? Because it is because of the motion of the unpaired nucleons. The nucleons which are being unpaired, as you know about the electronic configurations. So if I am taking the example of sodium, then sodium will be having 1s2, 2s2, 2p6 and 3s1 configuration. So it is having the one unpaired electron. So why the movement will be occurring in within the nucleus of the sodium, it is because of that 3s1 electron which is being unpaired electron. So like that, in case of nucleons also, as it is having the number of nucleons will be equals to the number of electrons will be equals to the number of protons. So within the nucleus, as we have seen in the shell model, the fitting will be just like that. As per the shell model, we have seen how the that just like that of above principle or and Hund's rule of maximum multiplicity and all those things, how the nucleons are being fitted within the nucleus, we have seen all those things in the shell model. So the movement of the nucleus as a whole is because of the motions of the unpaired nucleons. So just remember why the movement of nucleus is occurring, because of the unpaired nucleons. And in this way it conserves the essential feature of liquid drop model. So लिक्विड ड्रॉप मॉडल ने भी यही बताया था कि जो भी एक्सटर्नल फोर्स आता है या फिर जो भी तुम लोग टारगेट हिट करते हो उसकी वजह से न्यूक्लियॉन्स के अंदर चेंजेस होते हैं, तो न्यूक्लियॉन्स के अंदर जो चेंजेस होते हैं, ऑसिलेशंस होते हैं, उसकी वजह से उसका जो शेप होता है चेंज होता है, एंड देन इट फाइनली गेट्स स्प्लिटेड इनटू टू न्यूक्लियस. सो this essential feature the essential feature of the liquid drop model is being conserved here, and also retaining the concept of number of nucleons which are lying outside the filled shell from the shell model. तो यहाँ पे इस मॉडल में कलेक्टिव मॉडल retain the concept of shell models also by showing the concept of quantum numbers of nucleons which are lying outside the filled shell. So we are going to see now this. I think you got the statement for this. The model treats the movement of nucleus as a whole as a motion of unpaired electrons. So it retained the features of liquid drop model also and shell model also. Now first point, as there will be 4 points. Our first point is nuclear deformation due to nucleons outside the filled shells. So first point here is nuclear deformation. Why the nucleus is going to deform into ellipsoidal shape, critical state, dumbbell shape, and then finally into two nucleons? It is because of the nucleons which are present outside the filled shells. Nuclear deformation due to nucleons which are being present outside the filled shells. Now first point is that in that the starting point of the shell model appears to be the suggestion of Vren water, that nucleons lying outside the closed shells exert centrifugal pressure. Now just remember the word, the nucleons which are being lying outside the closed shells, they are exerting the centrifugal pressure which deforms the shape of the nucleus from sphericality. So the nucleons which are lying outside the closed shells, they are being acting as a projectile and they are exerting a centrifugal pressure, and thus they deform the shape of the nucleus from sphericality. Second point is that Bohr and Mortensen showed that nuclei thus deformed should execute vibrational and rotational motions. Now the nuclei which is being already deformed because of the outside nucleons, it will execute the vibrational as well as rotational motions, and thus nucleus behave as one collective unit. Somewhat like the motion of the polyatomic molecules. It implies that as it is being behaving as a collective unit because of the vibrational as well as rotational motions, the periodic oscillations in the nuclear, there will occur the periodic oscillations in the nuclear size and shape. And the causative factor for this is that for this nuclear motion, collective motion, is the number of nucleons outside the filled shells. The effect should increase in magnitude further if n and z they are from magic numbers. What we have seen here, the periodic oscillation in the, firstly we have seen the nucleons which are lying outside the closed shell, they are exerting the centrifugal pressure, and that because of that pressure it deforms the shape of nucleus from sphericality. So this was the first point. And then the nuclei which was thus deformed, it execute the vibrational as well as rotational motions, and thus the nucleus behave as a collective unit, and which implies that the periodic oscillations in there which implies that there occurs the periodic oscillations in the nuclear size as well as the shape because of that collective motions. And for this collective motion, the causative factor is the number of nucleons which are lying outside the filled shells, which we have seen in the first point. Causative factor for collective motion is number of nucleons which are lying outside the filled shells, and the effect will increase in magnitude if n and z, n atomic mass number and z is atomic number, if they are from the magic numbers. And hence with the increase in electric quadrupole moment, we can determine the total electric potential which are outside the filled shells. अगर वहां पे डिफॉर्मेशन होता है तो डिफॉर्मेशन जिस तरह से तुम लोगों ने डायपोल मोमेंट स्टडी किया हुआ है, अगर हम लोग न्यूक्लियस को दो मैग्नेट के बीच में रखते हैं तो एट दैट टाइम देयर ऑकर्स द क्रिएशन ऑफ डायपोल. तो उसी तरह से अगर हम कोई चारों साइड से अगर चेंजेस होते हैं, माना जिस तरह से हम लोगों ने देखा था कि अगर कोई भी तुम चीज यहाँ पे डालते हो तो इस तरह से वहां पे डायपोल क्रिएट होता है, पॉजिटिव एंड डेल नेगेटिव, ये तुम लोगों ने ऑलरेडी देखा हुआ है. तो इसी तरह से क्वाड्रुपोल होता है. क्वाड्रुपोल माना चारों साइड से वहां पे चेंजेस हो रहे हैं. तो चारों साइड से चेंजेस हो रहे हैं मतलब क्या होता है वहां पे कि अभी सिर्फ तुम लोगों ने दो साइड से चेंजेस देखे थे. यहाँ पे जो तुम्हारा स्पेरिकल शेप है वो प्रोलेट हो जाएगा, या फिर जिस तरह से संतरा होता है तो संतरा कैसे होता है, प्रोलेट शेप का होता है या फिर ऑब्लेट शेप का. कोणत्या शेप मध्ये झाला संतऱ्याला? ऑब्लेट स्पेरोडॉयल बोलते हैं उसको, ऑब्लेट स्पेरोडॉयल या फिर प्रोलेट शेप. तो उस टाइप में वहां पे चेंजेस होते हैं. तो यहाँ पे इधर भी चेंजेस हो गए तुम्हारा प्लस टेल एंड देन माइनस टेल, माना चारों साइड से चेंजेस वहां पे आते हैं. तो कंप्लीट स्पेरिकल नहीं रहता है, थोड़ा सा दबा हुआ होता है इन केस ऑफ quadrupole. So with the increase in electric quadrupole moment, we can determine the total electric potential outside the filled shells. Actually, the quadrupole moment of a highly deformed nucleus lying furthest from magic number is found to be many times larger than the attributable to a single odd particle of spin J. Just the quadrupole moment of a highly deformed nucleus which is lying furthest from the magic number, means it is not having the magic number, it is very far away from the magic number. And which are the magic numbers? 2, 8, 20, 50, 82 and 126. These are the magic numbers which we have seen in the shell model. So the nucleus which is having the quadrupole moment which is very away from that of the magic number is found to be many times larger than the value attributable to a single odd particle of spin J, and the latter value, that is Qj, that is the quadrupole moment of a highly deformed nucleus lying furthest from the magic number, is represented by the symbol Qj, and it is equal to the value minus twice J minus 1 divided by twice J plus 1. J will be the rotational quantum numbers, divided into 3 by 5 R square. The ratio of quadrupole moment, actual quadrupole moment Q, to that of the quadrupole moment of a deformed nucleus. Initially Q will be its actual quadrupole moment and Qj will be after deformation, is the measure of the number of nucleons moving collectively. In one case, this number is reported to be as high as 40. So what we have seen here in this case, the quadrupole moment of a highly deformed nucleus which is having the magic, which is lying furthest from that of magic numbers, it will have a very large value, and that value maybe can exceed as high as 40. So this was our first point, and within that first main point, this is our last sub point, that is fifth. Also, by this model, nuclear excitation may consist not only in the transfer of a nucleon or a few nucleon to a higher vacant levels, means as per this model वहाँ पे एक न्यूक्लियन या फिर थोड़े से न्यूक्लियन नहीं होते, तो बल्कि वहाँ पे बहुत सारे इन कलेक्टिव मोशन वहाँ पे बहुत सारे न्यूक्लियंस होते हैं. देयर विल बी मेनी न्यूक्लियंस व्हिच आर लाइंग आउटसाइड टुगेदर एंड दे विल लीड टू अ they will lead to higher rotational or vibrational quantum numbers for the group of nucleons as a whole of the अभी यहाँ पे हायर रोटेशनल और वाइब्रेशनल क्वांटम नंबर्स माना जो न्यूक्लियॉन्स है जब वो हायर ग्राउंड स्टेट से हायर स्टेट में अप कर रहे हैं, इस साइड में निकालते हो तो ये तुम्हारी ग्राउंड स्टेट है, तो ग्राउंड स्टेट से वो एक्साइटेड स्टेट में जब न्यूक्लियॉन्स जाते हैं तो एट दैट टाइम वहां पे तुम लोगों को पता है कि पहले ट्रांसलेशन एनर्जी लेवल होते हैं, फिर इलेक्ट्रॉनिक एनर्जी लेवल्स, फिर वाइब्रेशनल एनर्जी लेवल्स होती है, और उसके वाइब्रेशनल के बीच होती है तुम्हारी रोटेशनल एनर्जी लेवल्स। तो जब भी तुम्हारी वाइब्रेशनल एनर्जी लेवल हो रही है वहां पे, तो रोटेशनल एनर्जी लेवल्स वहां पे एसोसिएटेड है। तो इस तरह से वहां पे जब भी इलेक्ट्रॉन ग्राउंड स्टेट से इलेक्ट्रॉन है न्यूक्लियॉन्स जो भी होते हैं वो ग्राउंड स्टेट से अगर एक्साइटेड स्टेट में जाते हैं तो वहां पे जो एनर्जी, वहां पे जो क्वांटम नंबर्स चेंज हो रहे हैं, तो वहां पे ग्राउंड स्टेट टू एक्साइटेड स्टेट्स की ट्रांजिशन में वहां पे कुछ रोटेशनल ट्रांजिशन जाएंगे और कुछ वाइब्रेशनल ट्रांजिशन भी जाएंगे। सो दैट कलेक्टिव मोशन ऑफ मेनी न्यूक्लियॉन्स विल लीड टू हायर rotational as well as higher vibrational quantum numbers for the group of nucleons as a whole। और जब हम ये दोनों को कंपेयर करते हैं रोटेशनल और वाइब्रेशनल को, तो वहां पे जो रोटेशनल मोशंस होते हैं ज्यादा अच्छे से हम लोग अंडरस्टैंड कर सकते हैं। तो उसके लिए यहाँ पे दिया हुआ है 2 पॉइंट्स फॉर दिस, फॉर रोटेशनल मोशन। फर्स्ट है कलेक्टिव रोटेशन इन इवन न्यूक्लाई एंड सेकंड पॉइंट है कलेक्टिव रोटेशन इन इवन ऑड न्यूक्लाई। तो एक बार हम लोग ये जो अभी हमने देखा इसको एक बार सिर्फ रिवाइज करते हैं। तो मेन थीम क्या थी? द न्यूक्लियर डिफॉर्मेशन ड्यू टू न्यूक्लियॉन्स विच आर लाइंग आउटसाइड द फील्ड शेल्स। तो ये जो न्यूक्लियॉन्स होते हैं विच आर लाइंग आउटसाइड द क्लोज शेल्स, दे exert the centrifugal pressure and which deforms the shape of the nucleus from sphericality. So as the nuclei which is being thus deformed, it will execute the vibrational as well as the rotational motions, and thus the nucleus behave as one collective unit, and it implies that there will occur the periodic oscillation, and the causative factor for that collective motion is the number of nucleons which are outside the field shells, and the effect increases with the increase in the atomic number as well as atomic mass number from the magic numbers, and with the increase in the electric quadrupole moment we can determine the total electric potential outside the field shells. Actually, the quadrupole moment of a highly deformed nucleus, that is Qj value, to that of Q, which is the actual quadrupole moment, that is this one, to that of Qj, which is the quadrupole moment after deformation, it may be as high as 40 if the value is far larger from that of the magic number of the nucleons. They have given the examples, we will also see that. And the last point we have seen is that as per the also by this model, the nucleus excitation may consist not only in the transfer of a nucleon or a few nucleons, but in the collective motion there will be many nucleons which are being moving from ground state to excited state, and leads to the higher rotational as well as vibrational quantum numbers. And out of that rotational and vibrational quantum numbers, here we are going to see rotational motion. And in that rotational motion, we will see 2 points, that is collective rotation in even nuclei and collective rotation in even odd nuclei, odd even nuclei. So first is collective rotation in even nuclei. Just remember even. So first point here is the rotational band energies for even Z and even N. Z will be the atomic number and N will be the atomic mass number, and if both the values are even, in that case the rotational energy will be given by the factor h cross square, where h cross will be h upon 2 pi, h cross square divided by 2I. That I is the what I have written here, I, it is for the moment of inertia, in bracket I plus 1, which is the total angular momentum, this I. So where I means this I in bracket I plus 1 factor, it is the angular momentum of a nucleus which will have the values 0, 2, 4, 6, 8, and it will have the even parity For that parity, how to calculate the parity, I have shared one YouTube video which is already available on YouTube. I have just telecasted it on StreamYard and I have shared that with you. I hope you have seen that. Then, what is this moment of inertia factor? The moment of inertia of the deformed nucleus, whose magnitude increases with the extent of deviation from sphericality. The lowest excitation state here is +2, and the next will be so on. As firstly, we will see this diagram. As you can see here, these are the rotational level of plutonium, which is having the atomic number 94 and atomic mass number 238. So the number of neutrons will be there 238 minus 94, which will be equals to 144, and it is having the spin as well as parity, which is given. So its lowest excitation state is +2, and these are the 4, 6, these are the higher excited state. So the lowest excitation state, as you can see here, is +2, and the next will be +4, +6, +8, etc. The plus factor is for parity. The ratio of energy of higher excitation state, that is 4 plus, 6 plus, etc., to that of lowest excitation state is given by the above equation, which is this one, that is E rotational is equal to h cross square twice moment of inertia into I in bracket I plus 1, where I is the total angular momentum. So if you are knowing the lowest excitation state and that of the higher excitation state, then you can calculate the rotational energy for the transitions. And is given by the following table with the values observed in the rotational bands of nuclide 94 plutonium. Just remember this element which they have used here, 94 plutonium 238, which is a typical of nuclides far removed from magic numbers as expected for of both, that is Z and A. Now, as the plutonium is not having the magic number of nucleons, so in that case, how the changes is occurring? So the ratio of higher excitation energy to that of lower excitation energy in even Z and even nuclides, as we have seen the meson theory, where we have shown that if the nucleus is having the even number of mass number and even atomic number, then in that case it will be more stable. And here in the, but they are not having the magic numbers, they are having the even numbers, but the magic numbers which give more stability. So for that they have given this table where they have given you the ratio of higher excited state to that of the lower excited state, then the value expected on the earlier equation, and value observed for plutonium 238, means theoretical value and observed value. So theoretical value matches with that of the observed value. As you can see here, for force for E4 divided by E2, the value will be, it's E4 means you have to multiply it by 5 and 2, so multiplied by it by 3. 6 है यहाँ पे, तो 6 को 7 से मल्टीप्लाई करो, 8 है तो 9 से मल्टीप्लाई करो, और उसके नेक्स्ट लेवल जो उससे उसको मल्टीप्लाई करो, देन यू विल गेट द इक्वेशन. एंड यहाँ पे ये तुम लोग देख सकते हो, यहाँ पे ये जो वैल्यू आई है वो 3.33 है, तो ऑब्जर्व वैल्यू जो है 3.32 है. देन यहाँ पे वैल्यू जो है E6 बाय E2 के लिए 7.0 आई है, तो यहाँ पे जो वैल्यू तुम्हारी 6.91 आई है. यहाँ पे तुम लोग देख सकते हो वैल्यू तुम्हारी 12 आई है, तो यहाँ पे ऑब्जर्व वैल्यू जो है उसकी 11.68 है, मीन्स theoretical value matches with that of the observed value. So the value of the so in this way you can calculate the values for rotational energy levels. So the value for the ratio of A4 by A2 observed in case of several even nuclides lying far from the magic numbers are close to theoretical value. So if the molecule which you are being choosing, if the element which you are being choosing, if it is having the even number of nuclides, which may not have the magic numbers. In that case, E4 by E2 value matches with the theoretical value. The observed value for E4 by E2 matches with that of the theoretical value. But if for that they have given the some examples. For example, hafnium 72, hafnium 180, 88 radium 226, 90 thorium 230, 98 californium 250, and they are having the values nearly in the range of 3. E4 by E2 value for hafnium is 3.32, for radium is 3.09, for thorium is 3.28, and for californium it is 3.39. It means they are nearly having in the range of 3. And these are, and here the theoretical value matches with that of the observed value. But if the element is having double magic number, if it is having the atomic number as well as atomic mass number, both are having the magic numbers. For example, 82 lead 208, which is having the magic number 82 also, and 208 means there will be number of neutrons will be 126, means both will be magic numbers. So it is having the double magic number. So in that case, with the minimum deformation, it has the E4 by E2 ratio 1.2. As it is having E2 by E4 ratio 1.2, it shows it is hard to deform the rigid structure, because as it is having the double magic numbers, so it will be more stable, and as it is more stable, so it will be very hard to deform the rigid structure. That is, it will be hard to deform it from sphericality. So what we have seen in even nuclei, collective rotation in even nuclei. So here in this case we have just written there in one equation, that is E rotation is equal to h cross square twice moment of inertia into I in bracket I plus 1, where I is the angular momentum. And then we have seen this diagram where they have given the spin and parity values. Parity is plus and spin is 0 to 6, like that. And they have given the energy values also there. So the lowest excitation there is +2, and the highest you can see +4, 6, +6, +8, etc. And so the ratio of higher energy to that of the lowest excitation state is given by that above equation. So by using this equation, they have given one table for the nuclei which is having the even number of nucleons. So in that case, the theoretical value matches with that of the observed value, as we can see there. For the different E2 by E4 by E2 ratio, E6 by E2 ratio, E8 by E2 ratio. And then they have given some another examples also. So this table was for plutonium 238, 94 plutonium 238, and the next table is for different elements which are having some even nuclides. So in this case, they have given the different elements, and for all nearly they are having the value of E4 by E2 ratio in the range of 3.33. And there also, if these are the nuclei which are having the even nuclides, there the theoretical value of E4 by E2 matches with that of the observed value. And lastly, we have seen here the double magic numbers. If some element is there which is having the double magic number, as in case of 82 lead 208, it will be having double magic number, that is number of protons will be equal to 82 and number of neutrons will be equal to 126. So there are double magic numbers. So it has the E4 by E2 ratio 1.2. As the E4 by E2 ratio is 1.2, it means it is very hard to deform the rigid structure. Now, third point is collective rotation odd even nuclei. Firstly, we have seen odd or even nuclei. Now for odd even nuclei, which are having the additional quantum numbers. So in this case, the collective rotation of outer line nucleons of odd atomic numbers nucleus, the effective angular momentum cannot be taken as the only rotational value of the single odd nucleon, and these nuclei deviate from the spherical shape to a prolet or a oblate spheroid, possessing an axis of symmetry all the same. The resultant angular momentum here, that is I value, will be the sum of particle angular momentum and the collective motion angular momentum, which is shown in this figure. So as you can see here, in case of collective rotation of odd A nuclei, odd A means which are having odd even, it is not odd even, it is odd A, means the nuclei which is having the odd atomic mass numbers. So in that case, the collective rotation of outer line nucleons, the effective angular momentum cannot be just taken as the J value, but it will be the summation of particle angular momentum, that is J, as well as the collective motion angular momentum, which is I. So here the value J value, this is the J value and this is the I value. So this will be the R will be the resultant value. So when you have to take the angular momentum I value to calculate the E rotational energy, that is E rotational, so in that case you will have to take a collection of particle angular momentum as well as collective motion angular momentum, that is J and I. Where you can see in this figure, they have shows this is the drop down factor and this is the value for ohm, where ohm and k, these are the quantum number in collective rotation. Then J is the odd nucleon total angular momentum quantum number, R is the collective motion angular momentum quantum number, I is the resultant of vector addition of J and R. So this I is the I is the vector, this I is the vector addition of these two, that is J and R. Ohm is the projection of J on symmetry axis. So they have drawn this symmetry axis here, and this is the J, this was our J, and this is the extension of J on the symmetry axis. So that ohm is the projection of J on the symmetry axis and K is the projection of I. This K factor is the projection of I on the symmetry axis. The projection of J and I on symmetry axis gives new quantum numbers, that is ohm and k respectively, in a given rotation band. Ohm and k retain constant values. So from that, the energy of rotation of odd A nuclei is given by the formula, that is E rotational will be equals to h cross square upon twice I, which will be the moment of inertia factor. This is the moment of inertia factor, and in bracket I plus 1 minus I0 in bracket I0 plus 1. So this is the change in this equation. In case of nuclei which is having the odd atomic mass numbers. Now merits, last point is the merits of collective model. So in case of odd A nuclei, what we have seen is you have to remember this diagram for that odd A nuclei. In this case, the collective motor, you have to take the collective angular momentum. You just can't add for resultant angular momentum, that is I, the particle angular momentum, that is J, and collective motion of angular momentum, that is R. You have to combine J and R in order to get the resultant angular momentum, and with that your expression changes for calculating the energy of rotation, which is equals to this. Now lastly, merits. The case of I0 is equal to half involves more complicated treatment. Here I may have the values I0, I0 plus 1, I0 plus 2, etc. and the ground state spin for I0 will be equals to 3 by 2, 5 by 2, etc. Now lastly, the merits of the collective model. First point is that it accounts for the observed rotational energy levels of nuclei for this removed from the magic numbers. So as you can now just remember, it explained the odd even nuclei, even nuclei rotational quantum numbers. So if the nuclei is having the nucleons away from that of the magic numbers, then in that case how the rotational changes occurs, it has shown that. from that E4 by E2 ratio. Then second point, it predicts the correct cross section for Coulombic excitation and for probability of E2 transition. Then third point, it explains consistently several other nuclear properties as magnetic moments, high quadrupole moment, isomeric transition of nuclei, which are far from the magic numbers. So these are the three merits. Firstly, it accounts for the observed rotational energy levels of nuclei which are lying furthest from the magic numbers. Second, it predicts the correct cross section for Coulombic excitation and for the probability of E2 transition. And third, it explains consistently several other properties like that of nuclear properties as magnetic moment, quadrupole moment, and isomeric transition of nuclei which are far from the magic numbers. So this is all about the collective model where we have seen the 4 points, main 4 points. First, first in introduction we have to write just demerits. There will be two demerits. Then we have seen their statement which combines both the liquid drop model and shell model. And then first point was nuclear deformation due to nucleons outside the filled shell. Then second, in that there we have seen the 5 subpoints. And then in that five subpoint, fifth subpoint tells about the rotational transition to be considered. And in that fifth subpoint there will be two another points which is collective rotation in even nuclei and collective rotation in odd A nuclei, and lastly merits. So this is all about today's lecture. I will share this PDF with you, and I will share that I have taken this PDF from the book. I have taken these notes from the book of nuclear chemistry by Arniker. So you can use that book also. It is available online also, but you can't print it. You just can read it. Nuclear chemistry by Arniker. Thank you.
Ma'am,
Wait.